that may be used while doing our proofs. Okay, so let's talk about the addition property. Just on a sidebar, I know this is not in your notes. If I gave you a problem like this, x minus 5 is equal to 10, what would you do to solve for x? You would add 5 to both sides, right? And you would end up with x equals 15, right? It's true, right? So what do? Well, we added 5 to both sides of the equal sign to keep it the same. If instead of an x, I just made it 6 equals 6, and I added 5 to both sides, does my statement still stay true? 6 plus 5 is not equal to 6 plus 5? Yeah, it is, right? So if you add anything to either side of an equal sign, it keeps it a true statement. So let's not think about it with numbers, and let's think about it with variables and actual letters. So if we had something like, if A is equal to B, then what the addition property of equality, because it keeps things equal with that equal sign, tells us that we can add any number, let's say C, to both sides of our equation, and it's still going to stay the same. So if A equals B, then it must be true that A plus C is equal to B plus C. That's your addition property of equality. Okay, the same thing can hold true for angles and shapes. I'm going to go to a blank screen here for 2 seconds. Just watch, don't write this. If I had something like line segment, or the length of AB is equal to the length of CD. Okay, so I tell you those are true. And then all of a sudden I do the length of AB plus the length of EF is equal to CD plus EF. What did I add to both sides of the equation? EF, right? I could easily subtract EF from both sides and that would get me back to the original, right? So your addition property of equality says that you can add the same thing to both sides and it'll still keep it the same. If I turn this into a congruent symbol and turn these into line segments, because remember line segments aren't equal, their lengths are equal, but the line segments themselves are congruent. Now what I just did is I turned this into an addition property of congruence, because it's a congruence statement instead of an equal sign, right? So we see the difference? So, addition property of congruence. If I take away that congruent symbol and turn this into the lengths, now I have an addition property of equality. Okay? So, adding two things to both sides. So pretty much if you see a plus sign, oops, I'm not going to have that old one. If you have a plus sign on both sides of the equal sign, it's addition property of equality. All right, so subtraction property. Same idea. If A is equal to B, then it is true that I can subtract a number C from both sides. So A minus C would be equal to B minus C. Isn't it true if I subtract 5 from both 6's, I still have an equal statement? Right. If I turn my original equation that I had up here to x plus 5, what would you do to both sides? You would subtract 5 from both sides to get x by itself, right? Okay, so that's your subtraction property. Multiplication. Instead of adding 5 to 6, does it still stay true on either side if I multiply both sides by 5? Yep, so that's your multiplication. So if A equals B again, so A equals B, then it is true that we can multiply both A and B by C, and it would stay the same. Okay. Division, same thing. If A is equal to B, then I can divide both those numbers or line segments or angles by the same number, and it'll keep it the same. All right, so addition, subtraction, multiplication, division. The substitution property, you've already kind of done substitution. What does it mean when you substitute something? Maddie?
You find like a variable and then you put it into...
Right, so you substitute it. So remember, we did substitution back when we had problems like this, where we said, you know, the measure of angle ABC is equal to 84 degrees, x plus 2, 3x minus 5, this plus this equals 84. And then we would substitute x back in to get the degrees of the angles. Remember doing that in chapter 1? So substitution works when you substitute something in place of something. So for example, if we say that A is equal to B, and B is equal to C, I can substitute this value of C in place of that B. So ultimately this is going into that. So then I could say then A is equal to C. Okay, substitution. Addition property, subtraction property, multiplication property, and division property all either have equality or congruence depending on what the symbol is. A substitution property only works when it is an equation, so when there is an equal sign. You cannot do substitution when there's congruent symbols. Okay? All right, so let's see if we remember how to solve equations. So here we are given an equation, 3x plus 8 equals negative 4x minus 34. It is solved for us. We are going to justify each step over here under the reasons column. So whenever you are given something, that's always your first line, and under the reasons you will write given. That's true for any proof. Whatever you are given, whether it's an equation or whether it's some type of statement, you'll put the statement on the left and you'll write given on the right. All right, so now let's see what's happening from the first line to the next line. What changed on the left side of the equal sign?
Plus 4.
There's an extra plus 4x. Over here, there's an extra plus 4x. Why did they add 4x to both sides? To move this to the other side, right? The negative 4x. So because we added 4x's to both sides, that would be which property? Good. So we're going to write out addition. The only thing I'll let you be lazy about is writing the word prop for property. So the addition property of, and I'll let you put a little equal sign for equality instead of writing equality out. Okay? All right. What happened from line 2 to line 3? Say again. Not yet. That would be from 3 to 4. What happened here? From here to here? They combined like terms, right? So you can either write the words combine like terms, or you can just write the word simplify. As we get good with this, we'll just skip the simplify parts. Then they did what, Michaela? Now they subtracted 8 from both sides, right? So that would be your subtraction property of equality. So subtraction prop of equality. What's your next move? What did they do? Yeah, so they simplified. So they combine like terms. 8 minus 8 is 0. Negative 34, negative 8 makes you get negative 42. And then what was the last step? Division. Good, they divided by 7. So that's your division property of equality. Okay? This is the basis of a proof. You write a bunch of statements on the left, and you have to justify your reasons on the right. Okay? This is pretty basic because you know how to solve equations, so this shouldn't be too challenging for you. All right, let's add another property to the mix. Distributive property, what does that look like? Distributive property. If we have A times B plus C, what results do you get when you do the distributive property? Yeah, so then you would get A, B plus AC when you distribute, right? Okay. Now I do want you to think about the distributive property a little bit in reverse because this does happen often. Sometimes you'll see something look like this. Let's say 2 times AB. Actually, let's make this be capital letters AB, sorry. Turn this into capital letters. So 2 times AB. Well, that's the same as taking AB plus AB. True? To double something, to add something twice is the same as doubling it?
Yes.
Okay. So a lot of times the way the distributive property is used in proofs is you'll see something like this, 2 times AB. We use this a lot when we're proving midpoints. That happens a lot using midpoints because what's true about a midpoint? It's exactly in the middle. So this side is equal to this side. So it's double to get to the whole thing. So if you see anything with parentheses, pretty much you're going to be using the distributive property. So just kind of keep that in your head. If I see something involving parentheses, distributive property. Okay, so flip on to the back. Let's see if we can work through one without the steps given for us. So we're going to set ourselves up with a T-chart. All of our proofs that we will be doing are 2-column proofs. So to organize ourselves, we make ourselves a T-chart. We're going to put our statements on the left and reasons on the right. And this is how every single proof always gets set up. Me personally, I like to label my lines 1, 2, 3, 4, 5, 6. You do not need to do that. I just do it for myself to keep things organized. So for line 1, you always start out with what they give you. And in this case, they're giving us an equation to solve. So I'm going to write line 1 is 60 equals -3 parentheses 8x minus 4. I'm going to put line 1 over here so it matches up, is my given. Okay, so what would be the next first move you would use? Distributive property, good. So using the distributive property, 60 stays. So I get 60 equals -3 times 8x, it's -24x. -3 times a -4 is a positive 12. My justification on the right would be the distributive property. All right, what would be your next move? Yeah. So now, so we can ignore the whole simplifying process, let's make line 3 be the number already subtracted by 12. If you need to put like a little tiny -12 here, -12 here, just to kind of help you to figure out what it's going to turn into, feel free to do that. But let's make line 3 already be the simplified version so we can do less writing. So 60 minus 12 gets us to, what, 48? So 48 equals -24x. What's our justification on the other side? What did we just do? Subtraction property. So subtraction property of equality. And then your last move would be to do what? divide, so 48 divided by negative 24 is negative 2 is equal to x. Division property of equality. Okay, now pay very close attention. My x right now is on my right side, so I want to make sure I write it on the right side. It's a whole different property. If I were to rewrite it as x equals negative 2, which we're in the habit of doing, I would have to do a whole nother step and add another reason, property of why you can do that. Okay? Questions with this? You think you got this? Okay, so now let's start taking it into the geometric world. So let's remember, back to chapter 1, some of our postulates that we've already been introduced to. Angle addition postulate. Remember this example up here I talked about where we did this plus this equals this? We did that back in chapter 1 because of the angle addition postulate. Well, that's going to be used a lot when we're talking about proofs. Angle addition postulate. Now let's just kind of make it generic. Let's say we would do the measure of angle ABC would be equal to the measure of angle ABD plus the measure of angle DBC. What's the difference between this statement and our addition property of equality? They both have pluses in them. It's only adding on one side of the equal sign, right? I don't have a plus sign on the other side of the equal sign, okay? So if you see something with a plus, and there's only one plus as opposed to two pluses, don't make it the addition property. Think about what other addition postulates did we talk about? Angle addition postulate, if we're talking about angles. Your segment addition postulate is the same thing, just with segments. So we could say AC is equal to AB plus BC would be your segment addition postulate. Right? If I make the little diagram, AC is equal to AB plus BC, never doing those problems. Okay. All right, let's talk definitions. Perpendicular lines, we just introduced that in the beginning of chapter 2. What do perpendicular lines do? If lines are perpendicular, is everybody okay with me using the symbol for perpendicular? Let me try to use symbols to write less things. So if lines are perpendicular, then what? What do perpendicular lines do? They intersect at 90 degrees. Then they intersect at 90-degree angles. I'm going to use this symbol a lot for angles. You are welcome to do the same. Just an angle with an S there for plural of angles. Okay? All right, so these we already know about, so let's use them for the next proof. You ready? So we are given that the measure of angle AOC equals 139 degrees. We need to solve for x and justify each step. So let's go ahead and set up our T-chart. Statements on the left, reasons on the right. Line 1 is going to be what? What is given to us? What is given to us? Good. The measure of angle AOC equals 139 degrees. Given. Now, if we were back in chapter 1, what would you do? We would say, oh, I could just do x plus 2x plus 10 and equal it to 139. Start solving, right? I'm going to plug it back in and probably get the two angles. But now we're doing a proof, so we have to justify every single reason. Well, what postulate allows me to do this?
Addition.
Which postulate allows us to do this? No. We just talked about two postulates, right? Directly above this example. Which postulate? Well, we're not, angle addition, right? So we're adding angles together to equal it to the whole. Okay, so before we can get to this, we have to make a statement about what the angle addition postulate allows us to do. And in order to do that, we have to actually physically put in the names of the angles that we are adding. So my line 2 is going to be the measure of angle AOC is equal to, now I'm going to run out of space, I'm going to have to go below, these two angles added together. So the measure of angle AOB plus the measure of angle BOC. So when we do our proofs, you must show what the actual addition is with the names of the angles. We can't just jump right to the equation right away. My justification on the right would be the angle addition postulate. Try to remember the difference between which ones are postulates and properties. Am I going to be super picky about it? No, but you should know that this is a postulate and not a property. All right, now let's do the work to get our x's involved there. So which property, I think Maddie talked about this, allows me to put in place of the measure of angle AOC 139 degrees? Which property says I can put something in place of something? Substitution, right? So I'm putting 139 in place of AOC. What am I going to substitute in place of the measure of angle AOB? X. And the measure of angle BOC is 2x plus 10. So what did we just do? We used our substitution property of equality, or just substitution property. All right, what would be your next move? Now we're back into familiar territory. What would be line 4? Yeah, I combine our like terms, so I get 139 is equal to 3x plus 10, which is a good old simplify. Then we would subtract 10, which would get me 129 is equal to 3x, which is a subtraction property of equality. And then our last move would be to divide. So we get 43 is equal to x, which is our division. If you want to do little ditto marks, feel free to do that. If you don't want to keep rewriting property of equality, I'll allow you to do that to be lazy. But yeah, so solve for x, done. Did we justify our steps? Yes. Okay. Questions with anything like that? All right, so now let's add in a few more properties into our lives. All right, so we've got 3 different properties that we need to discuss. They look a little bit different depending on which geometric figure we're talking about, whether it's a segment or an angle measure. So if we talk about reflexive properties of equality, if you look in a mirror, you see your reflection, what do you see?
I'm sorry.
You see yourself, right? So you see exactly what you're looking at. So the reflexive property of equality is where you see the exact same thing. So for geometry, the length of AB is equal to itself, the length of AB. That would be the reflexive property of equality. Now up in this title here, put a little slash. Let's do the same thing for congruence, because we need to be able to tell the difference. So that's our segment length reflexive property of equality. Let's put a little slash. If I were to do it for congruence, it would be line segment AB is congruent to line segment AB. Okay? Remember, lengths can be equal. 5 can equal 5. The length of the segment could be 5 centimeters, let's say. The length of that would be 5 centimeters. So lengths can be equal. Physical line segments, when we put the symbol above for line segments, can only be congruent. Same thing applies for angles. I could say angle A equals, or sorry, the measure of angle A is equal to the measure of angle A. Because the measures of angles can be equal. Angles themselves can be congruent. So here we have reflexive property of equality. After the slash, we have reflexive property of congruence. See the difference? One has an equal sign, one has a congruent sign. Okay, so reflexive is easy. You need the same thing on both the sides of the equal sign or the congruent sign. The next one is your symmetric property. So symmetric property tells us that if we have something like AB is equal to CD, then CD is equal to AB. So what happened from the hypothesis to the conclusion of that conditional statement? We just switched the order, right? So if we go back to those problems where we had something like negative 43 is equal to x, if I wanted to add an extra step and say x is equal to negative 43, well, I'm allowed to do that because of the symmetric property of equality. Right? That would be the purpose of using the symmetric property, is just to change the order of something. Do we use it that often? No. But that's why it's there. Okay, the same thing would work for congruence. If I turn these into line segments and then put a congruent sign over the equal sign, then it would be the symmetric property of congruence. Right? I won't make you rewrite that. And then the same thing works for angle measures. So if the measure of angle A is equal to, the measure of angle B, then the measure of angle B is equal to the measure of angle A. So you're just reordering things to flip them around. The symmetric property is not used that often. The two that are used the most is the reflexive property, is used a lot, and then this last one, which is the transitive property. All right, so your transitive property tells us that we can do the following. So if AB is equal to CD and CD is equal to EF. Now let's think about this. I have 3 line segments occurring. I'll do it on here. I have line segment AB. I have line segment CD. And I have line segment EF. If it's telling me that AB is the same length as CD, and CD is the same length of EF, well then isn't it true that AB and EF would also be the same length? Yeah, that's your transitive property. Notice, it's kind of like the law of syllogism. What is the length that they have in common? CD. So if you take out the length, what are you left with? The beginning and the end. So then we could say then AB is equal to EF. Okay? The transitive property and the substitution property are very, very similar. And they can be used interchangeably sometimes. Like sometimes you can use the substitution property when it could be the transitive property and vice versa. The only time the substitution property and the transitive property cannot be interchanged is when we're talking about congruence. So if I put line segments above this and put a congruent symbol above my equal sign, then it only can be transitive property. Substitution property does not work in congruence. It only works in equality. All right, and then the same thing is true for angles. So if the measure of angle A is equal to the measure of angle B, and the measure of angle B is equal to the measure of angle C, then the measure of angle A equals the measure of angle C. So they're both connected to B, which then makes A and C have to be the same. Okay. All right, so the last example we have 4 different statements, and we need to verify which property is being used. So for A, we have angle K is congruent to angle K. Reflexive, symmetric, transitive. Reflexive, good. So it is reflexive property. If you just write reflexive property, I am happy. Technically, we should be specific and say that this is the reflexive property of congruence. It has a congruent symbol. But if you just get reflexive property, I'll be happy. Part B, what's happening from my hypothesis to my conclusion? They added 8 to both sides. So that is the addition property of equality. All right, let's look at C. If line segment RS is congruent to line segment TW, and TW is congruent to PQ, then RS must be congruent to PQ. Which one's that? Yeah, right, because what's the link? The link is TW, so that would be the transitive. If that was all equal signs, then you could have used substitution. But it's not equal signs, it's congruent. So transitive property of congruence. And the last one, if the measure of angle A equals the measure of angle B, the measure of angle B equals the measure of angle A, is your symmetric property of equality. Okay, or just write symmetric property, I'll be content with that. Okay? All right, so I'm going to give you your homework.